Okay, everyone, we'll go ahead and get started. I'd like to welcome you all to today's webinar. Today we'll be going over just how to map I/O, both digital and analog, into the FC6A series PLCs. Again, here's just a copy of the current webinar schedule. Like Elias mentioned yesterday, we will not be doing webinars on Fridays starting this week. So we'll do Monday through Thursday this week and Monday through Thursday the following week, and a little bit into the week after that. And then we'll kind of see where we are at that point. There is the link if you want to go to our YouTube channel to watch any of the ones that we've already done back. You are certainly welcome to take a screen capture of that. So you've got it. So again, today we're doing I/O mapping. Tomorrow, Mr. Kirk will get into just basic circuitry in the PLCs, start-stop circuits, sets and resets. His presentation actually is very good. It's going to go pretty in-depth into the basics, really, of different kinds of circuits, going down to gate level stuff, which is just a good reference for when you're starting to design your systems. So should be an excellent webinar tomorrow. And then on Thursday, we will be going over timers. Mr. Gloysel will be doing that for us. Okay. For any of you who may not have gotten the email yet and you want to go get the material from each webinar, there's the link. Again, you guys are free to take a screen capture of that as well if you like. That's the link where you can go to get all of the materials from all of the webinars that we've done, and even the ones that we will be doing in the future will be there as well. Each webinar is listed, and then there's a download link just to the right of the webinar name. If you click on that, that'll download a zip file of all of the materials from that particular webinar. So you guys can go and get that. And again, these are being recorded, again, posted to the YouTube channel. You will also get a PDF copy of the presentation. You'll get any of the programs that we developed during the webinar, and you'll also get a question and answer document that we put together from both sessions of that particular topic. Okay. So again, for anyone who may not have attended one of these yet, if you want to ask a question, just click on your questions drop down, type your question, hit send. And at the end of the webinar, we will go over the questions and hopefully be able to provide you with some answers. The most popular question I've been getting lately is what day it is. So today is Tuesday. And I stole that from a TV station in Cleveland, Ohio. But good information nonetheless. All right. And for anyone who, again, who may be new or just doesn't recognize my voice, this is Britt Davis. I'm one of the automation managers for IDEC based out of Cincinnati, Ohio. All right, so before we start looking at the ways that we map the I/O, let's just take a quick look to see what I/O can we use with each of these different PLCs. As we've mentioned throughout some of the webinars, we've got two different styles of FC6A PLCs. There's ones that we call the all-in-ones. We used to call them bricks. And then we've also got the FC6A Plus. We used to call those home-style PLCs. And so the bricks are available in 16, 24, and 40 I/O, just on the CPU itself. You can add up to 15 I/O cards, and you can put any card anywhere. For those of you who have used our FC4A, FC5A PLCs in the past, you'll remember that the analog cards in those PLCs had to go in the first 7 positions, or first 7 slots, if you will. With the FC6A series, that limitation is no longer applicable. You can put any card anywhere. Now, the 16 I/O PLC, which is the baby of the bunch, you can have up to 4 I/O cards. Then you need to add an expansion power supply that goes right onto the last I/O card. Basically, it snaps into that. Then after that expansion power supply, you can add 8 additional cards. So the 16 I/O will support a total of up to 12 cards. And again, that's with that expansion power supply. The 24 and the 40 IO PLCs, you can have up to 7 IO cards before you need to add an expansion power supply. And then once you add that expansion power supply, you can have an additional 8 cards after that, for a total of up to 15 cards. On the, what I call the face or the front of the PLC, you can add up to 2 cartridges. Again, just depending on the PLC model. Like the 16 IO, the 24 IO support 1 card. The 40 will support 2 cartridges, cartridges, not cards. So on the face of the PLC where it plugs in right on the front, and you can see here I've got an example. This is a 40 IO PLC. You can see just to the left of where we have all the LED indicators, you can see there's 2 cartridges plugged in there, okay? And you can plug in serial cartridges, the Bluetooth cartridge, analog IO cartridges, or digital IO cartridges. Can be snapped right into the face. With the brick PLC, we've also got an optional HMI module. You can see that all the way to the left there. Again, what that lets you do is, if you need to add email, text, or web capability to an FC6A brick or an FC6A all-in-one, this is how you do it. You can add on this HMI module, and it'll give you that capability. If you look at the bottom left corner of that HMI module, and again, that's all the way to the left on the left side of the PLC there, you can see you can also attach 1 additional IO cartridge to that if you need to. All right, now let's take a look at the FC6A Plus. Again, these are available in 16 and 32 IO CPUs. You can have up to 15 IO cards. Again, any card, anywhere. You can plug in up to 7 cards, then the expansion power supply, and then 8 additional cards after that. You can also add up to 2 cartridges by using the cartridge expansion module. Okay, and we'll show you that in just a second. You can also do remote IO, master, and slave modules on the FC6A Plus, which will allow you to extend that to up to about 2,000 digital IO or up to about 500 analog IO. And we'll go over an example of that in the software in just a moment. So this is the cartridge expansion module. Again, this is going to plug into the left side of the FC6A Plus. You can connect up to 2 cartridges, and you can see there you've got 2 slots. The top slot is slot 1. The bottom slot is slot 2. And again, you can use communication cartridges like serial cartridges, or we're showing an example there, the Bluetooth cartridge plugged in on the top. You can also use digital IO cartridges or analog IO cartridges. There are no restrictions on what cartridge can go in what slot. You can put any cartridge in any slot you want. All right. Of course, we do have a wide array of IO cards and cartridges to fit the needs of your application, whether you need analog inputs, analog outputs, digital inputs, relay outputs, transistor outputs. We've got all sorts of combinations to fit the needs of the market. We also have a serial communications card. Now, this plugs in just like an IO card. Okay. Each card can use RS-232 communications and or RS-45 communications. The reason I say that is each card has 2 serial ports on it, and either port can be configured as RS-232 or RS-45, or you can do one of each. That's fine. You can do a maximum of 15 of these cards in a total system. So in theory, if you just had the FC6A Plus PLC and you plugged in up to 15 of these cards, you could also use the expansion cartridge module to add an additional 2 cartridges to get an additional 2 ports. So you could do a maximum of up to 32 total serial ports. Okay. Now, this particular card does support maintenance protocol, which is IDEX protocol. Like if you're connecting an HMI to a PLC, we use maintenance protocol, which is what we call it. It also supports user communication. It also supports Modbus RTU as well as data link. As far as a maximum cable length, if you're doing RS-232 communications, the maximum cable length is 5 meters. If you're doing RS-45, the maximum cable length is 1,200 meters. And again, this is just a quick look at the communication cartridges. Again, we've got RS-232, 45, and a Bluetooth cartridge. All right. Now let's talk about digital I/O addressing. One of the things that may look a little funny to you when you start using IDEC PLCs is anything that is by nature a bit, a digital input, a digital output, or even an internal relay. Those are all octal-based addressed. In other words, we don't use 8s or 9s in the addresses. Now, the reason that we do this, IDEC has been making PLCs now for 40 years. And when we first started doing this, the CPU, the main brain of the PLC that was available at the time, was an 8-bit processor. So everything was based on an 8-bit bus. We didn't have, you had 8 bits to work with. So that's why all of our digital I/O and truly bit-based devices will have addresses from 0 through 7 with no 8s and 9s. Sure, we could have changed that over the years with the newer PLCs that have come out. But we decided not to, really for the simple fact of code compatibility between old PLCs and new PLCs. So, if you've got like an old Micro 1 out in the field that you need to upgrade, you can use an older version of WinLadder that supports the Micro 1 to grab the program. In that software, you can convert it to maybe an FC6A or even an FC6A PLC, save the file, open that file up in the newer version of WinLadder, and convert it to an FC6A without having to go in and remap all of your I/O. So it's pretty handy. But that's the method to the madness. That's why we did it. So anyway, the software will not let you put in an address that is invalid. So I can't put in input 8 or output 9. It won't let you. Okay? So you don't have to worry about it. Now, as far as expansion I/O, whenever we plug in any expansion cards, whether it's an expansion input or an expansion output to an FC6A PLC, the expansion card's addresses will always start with 30. Okay? So my first expansion input card, the addresses will start with I30. The first expansion output card, those addresses will start with Q30. Now, digital I/O addresses are based on the card's position relative to the PLC. So in other words, let's say I have a system where I have 2 digital I/O cards, okay, just the PLC and then 2 cards sitting next to each other. The first card will say it's a 8-point digital input, say they both are, just for example's sake. The first card would be input 30 through input 37. The second card would have addresses input 40 through input 47. Now, if I physically swap their positions, in other words, I take the card that's in position 2 and move it to position 1, take the card that was in position 1 and move it to position 2, that will change the addresses of those cards because it's based on the card's position relative to the PLC. We'll look at this in the software. It will make more sense to you. Now, analog I/O cards, they have absolutely zero effect on digital I/O addressing. Okay? In other words, I can drop analog cards in there wherever I want. Doesn't matter. They have no effect on the addresses of the digital cards. Now, when we're using digital I/O cartridges, okay, if you're plugging those into slot 1, those will use addresses 630 through 633. If you plug it into slot 2, that uses addresses 634 through 637. Okay? This is regardless of whether you're using input and or output cartridges. It doesn't matter. Okay? If it goes in the first slot, it's going to have 630 through 633 as the address, whether it's an input cartridge or an output cartridge. Doesn't matter. Same holds true for slot 2. All right, let's look at an example. So here I've got an FC6A PLC. This happens to be a plus. I've got 4 I/O cards out to the side. I've also got a cartridge expansion module with 2 cartridges plugged in. Card number 1 is an 8-point DC input. Again, since that's our first input card, the addresses start with 30, and it's an 8-point card, so those addresses are I-30 through I-37. My second card is an 8-point relay output card. Since that's my first output card, those addresses also start at 30. So that's going to be Q30 through Q37. My third card there is a 16-point digital input card. So since that has 16 points, my addresses will be input 40. Again, since it's the second input card, the addresses just continue based off the first card. So my first card was I-30 through I-37 on my inputs. My next input card, again, the addresses just roll right on out. So that'll have addresses I-40 through I-47 and I-50 through I-57. Again, that's a 16-point card there in slot 3. The fourth card is a 16-point relay output card. And again, those addresses are going to fall off based on my first relay output card, or my first output card just in general. Again, my first output card had addresses Q30 through Q37. So this second card, again, it's a 16-point output card. Addresses will start at Q40 and go from Q40 through Q47 and Q50 through Q57. Now let's take a look at the cartridges. And again, that's number 5 and number 6 in the graphic there. So cartridge in slot 1, which is the top slot, is number 5 in the graphic. That happens to be a 4-point transistor output card. And again, those addresses will start automatically with 630. So it doesn't matter if I had an input cartridge or an output cartridge there. In slot 1, the addresses start with 630. It's an output, so it's Q630 through Q633. Cartridge 2, which is in that bottom slot, slot number 2, that's a 4-point DC input cartridge. And again, slot 2 has addresses 634 through 637. All right. So let's take a look now at how we do analog I/O addressing. And if you've been around on some of these webinars before, you've seen some of this already. So with analog I/O, we specify data registers to determine where to store the values that are coming from the card and going out to the card. Okay. Analog I/O cards can have their configuration stored in and adjusted by values in data registers as well. And we'll look at that. The analog I/O cartridges use predefined special data registers. And if you guys remember, special data registers and special internal relays are areas in the PLC that just automatically exist. We've created them, we've defined their functionality in the firmware. You don't have to use, or you don't have to do anything to get them to work. They just do, okay? And the way that we've done this for the analog I/O cartridges is if you're using an analog I/O cartridge in slot 1, the data and information for that card will be stored in special data register D8170 through D8173. If you're using an analog cartridge in slot 2, that data will go into special data registers 8174 through 8177. And something else that we looked at when we did the scaling webinar a little bit, we talked about there's an FC6A compatibility mode checkbox whenever you set up analog I/O. And again, what that lets you do is if you're converting a program from an FC6A or an FC5A PLC, unfortunately, the I/O cards from that series will not work with the FC6A series. We wanted to make the FC6A the biggest and baddest PLC around, and we had to redesign the communications bus internally to do that, to make it faster so we could do more I/O and things like that. So the older I/O from the FC6A, FC5A series, you can't take those cards and put them on an FC6A PLC. But what FC6A compatibility mode does for you is in the software, you can pick your closest FC6A card that you're converting from, and it will use the same data register mapping as what that card used in the FC6A, FC5A program in the FC6A program. So in other words, you don't have to go through and remap all your analog I/O if you don't want to. You can use those same data registers that they were mapped to before in the FC6A, FC5A PLC, which is kind of handy. Okay. Here's an example. and we'll take a look at this too. We'll do a live example when we get into the software in just a moment. This is an example of configuring an FC6A J4CN1. You can see the part number there in the top left corner of the dialog. The DR allocation, the data register allocation, what that is it lets you specify the starting address where we want to store the information for this card. And again, in an example, we chose D1000. Off to the right there, still at the top, you can see the checkbox for FC4A compatible mode. And again, the FC4A I/O card that is most similar to the FC6A I/O card that we're working with in this example is the FC4A J4CN1. So if I'm converting a program that had an FC4A J4CN1 card set up, and if I click that compatible mode checkbox, what it's going to do is map the card data for the FC6A J4CN1. It's going to use those same data registers as the FC4A card did. Okay. And the checkbox below there, you can see it says use data register for setting parameters. Again, what that lets you do is you can configure everything about the card by adjusting values in data registers. You can adjust the signal type. Is it 0 to 10? Is it 4 to 20? Is it 0 to 20? Is it a thermocouple? Is it a RTD? You can adjust the data type. You can adjust the minimum values, maximum values. All that kind of stuff is available to be manipulated within data registers if you want. But that's what that checkbox will let you do. Down at the bottom of the dialog box there, you can see we've got a relay for writing parameters. And again, this is used in conjunction with the using data registers for setting the parameters. And again, that's a starting address. In this example, we just chose M1000, so that's going to use 3 internal relays, M1000, M1001, and M1002. So what M1000 will do is whenever you turn that bit on, that will write the parameters in the analog module down to the working data registers. Okay. M1002 is the opposite of that. It will take the values that are in the data registers and push that to the analog card. M1001 is kind of like our initialized bit. What M1001 will do is take the initial parameters that are stored in this configuration box, whatever you've configured by default and downloaded to the PLC. Whenever we turn on M1001, that will copy those values into the working registers. Okay. So again, there's 3 internal relays there that are used for moving data around, either back and forth between the registers and the analog card, or to reset to go back to the default settings that you initially had configured in the software. All right, now the FC6A Plus, that supports remote I/O. And I'll start up here at the top, and we'll kind of work from the top down and go through this. So at the very top, I've got node 0, my main PLC. I've also got an FC6A-EXM1M, and what that is a master remote I/O module. Okay, it's got an Ethernet port on it. Okay, you can see that there on the card, and it's got a blue line coming out of it, going to another thing, and we'll talk about that in a minute. But that thing has an Ethernet port. So after I plug that in, then I can connect up to 5 I/O cards. Okay. Then I need to connect an expansion power supply if I need any more I/O cards after that. Okay. So again, if I'm using a master remote I/O module, I can have up to 5 cards after it. Then I need to use an expansion power supply if I need to have additional I/O cards. Okay. And again, I can use up to 8 after that expansion power supply. So if I come down off of that expansion master remote I/O module there, if I'm looking at node 1, what that is going into, that blue line, that's not another PLC. That is an FC6A EXM1S. It's a slave remote I/O module. Okay, that has 2 Ethernet ports, one on the top, one on the bottom. Okay, and what that lets you do is you can connect that directly to the master module. Okay. So I come out of the master, I come down to my slave module. Then I can hang I/O off of that slave module just as if it were another regular PLC. Okay. I can use digital I/O cards, analog I/O cards, the special PID cards. I can plug that all in just like I normally do. You can have up to 15 I/O cards on each node, just like you can with the PLC. Again, if I would have, say, 7 I/O cards on node 1 and I needed more, again, I would drop in that expansion power supply, and I can have up to 8 I/O cards after that. Now for node 1, when I'm doing digital I/O, the I/O is automatically addressed for us, and it starts at 1000. Okay, so whenever I plug in a digital input card, it's going to start with I1000. My first digital output card will start at Q1000. Okay, if I work my way down there, I've got node 2, and the way that these slave modules are connected are they're basically daisy chained together over Ethernet. You can see I come out of my master module into the top port of my first slave module, node 1. I come out of node 1 on the bottom Ethernet port into the top node, or the top Ethernet port rather, of node 2, and so on. And you can connect that up to a total of 10 nodes. Okay. Now, the way the digital I/O gets addressed on each node, respectively, you can see node 2 there. Digital I/O, the inputs start at 2000, the outputs start at 2000. And they work the same way. Node 3, the digital I/O, inputs start at 3000, outputs start at 3000, and so on, all the way down to node 10, where the digital I/O, inputs start at 10,000 on node 10, outputs also start at 10,000 on node 10. Okay. Now, there is a total maximum number of I/O cards that you can use in a total system. Okay. The total maximum is 63 I/O cards on everything. Okay. So even though on each node you can put up to 15 total I/O cards, the overall system maximum is 63. Okay. All right. So let's look at some examples here. Let me go into WinLadder, and we'll just do a few different configurations just to kind of reinforce all the points in the PowerPoint. Okay. All right. So this is just, I just opened WinLadder. It's just a brand new program. There's nothing in here. The default PLC that I have set up is an FC6A D16, which you can see down there at the bottom left-hand corner of the software. And that's what's showing up here. Right. So let's just start out. Let me go ahead and I'll connect a couple of digital input cards and a couple of digital output cards, and we'll have a look at that. Minimize some of these boxes so we can see what's down below here a little easier. All right. So over here on the right-hand side, I've got all of my digital I/O cards, my digital I/O modules. They're all here to be selected from. So I'll just grab a couple at random, and I'm really not doing this in any particular fashion, just making sure I grab a couple of input cards and a couple output cards. Okay. So these two cards, and we can see here, these are digital input. So that first card is an FC6A N16B1, it's a digital input card. You can see that has addresses input 30 through input 37, as well as input 40 through input 47. Again, it's a digital input card, 16-bit, or 16 points, and it always starts with 30. Again, no matter what card I put there, it's going to start with I30. My next card is also a digital input card, the 32-point input card. Okay, and again, my last card was going from input 30 through input 47, right? So this second card will pick up right where the first one left off and go to 50. So this is a 32-point card, so my addresses are input 50 through 57, 60 through 67, 70 through 77, and 80 through 87. Okay. These last two cards are digital output cards. Okay. The card that I've got in position 3 here is a 16-point relay output card. And again, since that is my first output card, it starts with 30. So that's 16 points. So I'll have Q30 through Q37, Q40 through Q47. The card that I've got in the last position here is a 32-point transistor output card. And again, the addresses for this are going to roll right off of my first output card. Okay, my first digital output card ended at 47. So my next output card addresses start with 50. And again, this is a 32-point card, so I'll have output addresses 50 through 57, 60 through 67, 70 through 77, and 80 through 87. Okay. All right. Now, let's look at something as if I were to switch the position of these cards, right? If you remember in the presentation, I said that will affect the addresses. So in other words, what I'm going to do is I'm just going to flip the position of these input cards. I'm going to put this 32-point card right here in the first position. And I'm going to move this 16-point card into my second position. Okay, so let me do that. I'll just grab my 32-point card and slide it over here and drop it in. So that put my 32-point card in my first position, my 16-point card, again, these are both input cards, in the second position. But look at what it did to the addressing. Since I moved this, now this 32-point input card is the first digital I/O card that we come to after we have the PLC. So the 32-point input card here has addressing that starts with 30. Okay, so it goes from I30 through I67. My next digital input card, again, it rolls off the addresses of the first one, now starts at 70. So moving these cards around will affect the address. Okay, let's look at another example. Again, that third card that I have here is a 16-point output card. Okay, if I wanted to, for whatever reason, move that up into position 1 here, it will still be my first output card that comes after the PLC, right? These first two here are inputs. So if I were to move this relay output card up here into position 1, right? Again, that's still my first relay output card, so those addresses aren't going to change. That's still Q30 through Q37, Q40 through Q47, right? Again, because it's the first output card that I come to after the PLC. Now, if I were to take my 32-point transistor card that's on the end here and do the same thing, then that changes all the addresses again on the digital output cards. Now my 32-point card starts at Q30. My 16-point relay output card now starts at Q70. Again, the positioning of the card relative to the PLC for digital cards makes a difference. All right. Okay, let me go slap some analog on this thing. We'll take a look at that. So let me go here and grab an analog I/O module. Again, they're all listed here on the right-hand side. And I'll go ahead and grab that J4CN1 card just because. Left click to drop it in. Again, I can put this analog I/O card anywhere that I want. This will have absolutely no effect on the addressing of my other digital cards. None. Okay. So if I have my analog I/O card out here at the end, I click on configure to configure the card. Again, up here, I've got the type. It'll show the model number here in the top left-hand corner, FC6A J4CN1. My data register allocation, again, this is just a starting data register that I want to use to configure the card. I can use whatever data register I want as long as it's not a special data register. So for example, if I wanted this to be at, I don't know, data register 423 for whatever reason, I can do that. Out here to the side, it will show you the current number of data registers that are being used by this card. So if I don't do anything else, if I don't check any of these other boxes or do anything differently, this will use data registers 423 through 430. Okay. When we come down here, I'll configure each one of these channels. And again, I'm just going to make this up as I go along. I'll say maybe that's a 0 to 10 volt signal. Channel 1 might be a 0 to 20 signal. Channel 3 could be a thermocouple. And let's say channel 3 there, the last channel is an RTD. Again, I'm just picking that at random. Again, I can come over here and adjust the data type between binary data or optional range. Again, this is a 16-bit card, okay? And in 16 bits, you can have values ranging from 0 if all the bits are off to 65,535 if all 16 bits are on, and any combination in between there. Okay. Optional range, again, that basically allows you to scale the card within these settings, and this is based on each individual channel. So in other words, if I decided for whatever reason, instead of having the 0 to 20 milliamp signal go between 0 and 65,535 or minus 32,768 to plus 32,767, if I wanted it to be scaled between 0 and, I don't know, say 20,000, for example, I could do that. So what it'll do is basically scale linearly from 0 to 20 milliamps between my min and my max range, 0 to 20,000. Now for my thermocouple and my RTD down here, maybe I want to show those as a temperature, either in Fahrenheit or Celsius, and I can do that. It will give me the min and max range based on the signal type, based on the device I've selected, basically. So for a type R thermocouple, that's the range it can read in. If I change that to, like, say, a type K, for example, that will change my range. Okay. And the same thing holds true for my RTD. It will pump values between the min and max into this column of data registers here, right? So the data for my 0 to 10 volt signal will be stored in D423. From my 0 to 20 milliamp signal will be stored in D425. The data for my type K thermocouple will be stored in D427. And the data from my RTD here will be stored in D429. Now, if you guys remember from the scaling webinar that we did, remember, anytime we're reading a temperature from a thermocouple or an RTD, we're doing a little bit of cheating, right? Data registers are 16 bits, so they can certainly hold values from minus 328 to plus 2372, but they can't hold a floating point, right? If you guys remember, we looked at floating point data before, and we said that floating points take 32 bits or 2 consecutive registers to store. And what we're doing here to get around that, again, is we're taking whatever we read from the card, multiplying that by 10, and then storing it. So in other words, if here in my office, the temperature is 73.5 degrees, I'm not going to see 73.5 in D427, I would see 735. So when we go to the PLC, to actually get the temperature, we just need to convert the data type, and we've done this. This was done in the scaling webinar. We would convert the data in D427 from an integer into a float, and then do a division by 10 to get the actual temperature. And again, that's true of whether we're doing temperature based off of thermocouples or off of RTDs. We do the same thing. Okay. All right. These status registers here, D424, 26, 28, and 30. These store the status of each individual channel on the card. Those are good to monitor if you're doing any kind of control based off of these signals. That will tell you things like, is the channel getting data that it expects within the appropriate range? Do you have an open current loop? Things like that. And in the manual, it lists out all the different codes that are available that will be pumped into those status registers. so you can keep an eye on what your analog inputs are doing. Okay. All right. Now let me go up here. I'm going to click on this FC6A compatible mode. Again, this is using by default, just based on what I set up, data registers 423 through 430, right? If I click on this FC6A compatible mode box, then I can choose the FC6A card that most closely matches this one. And in this case, there's, from a functionality standpoint, there's basically an equivalent match. So I've only got one thing to choose from here, which is the J4CN1 in the FC6A series. You'll notice what happened. These registers that are used for the data and for the status just changed when I selected that checkbox. Now they're looking at D469, 470, 471, and 472 for the data, 477 through 480 for the status. Okay. Keep an eye on that area. I'll go ahead and uncheck this again, and you'll see it will go back to what it was before. Okay. So again, what that checkbox lets you do is if you're converting from an FC6A or an FC5A program to an FC6A, this will let you use the same registers that you did for your other analog cards in the FC6A, FC5A program. It'll do the mapping for you. Okay. So you don't have to remap everything, which is kind of nice. All right. Now, this bottom checkbox, I'm going to uncheck the compatible mode for now. I'm going to go look at this bottom checkbox that says use the data registers for setting parameters. Right. Again, by default, I was using D423 to D430. When I turn this on, okay, now what's going to happen is it's going to expand that and use D431 through D450 for storing all these different parameters about each channel. But again, I can view, I can manipulate in the PLC. That also opens up this area down at the bottom where I can specify an internal relay that I want to use for, again, adjusting these parameters, right? Again, M0 will write the parameters that are currently in the analog card down to these data registers. M2, in this example, since I used M0 as a starting internal relay, M2 will write the parameters that are currently in the data registers into the analog module. M1 will write the default values that we program in this dialog box down to the data registers. Okay. And again, you can think of M1 like an initialization input, if you will. Okay. If we click on this device allocation button here, what that'll do is it'll show me all the different data registers that I am using. Okay. Again, this is going from 423 through 450 now, since I'm using that checkbox to use the data registers to set the parameters, and it will show you here. Channel 0, the data and the status are in 423, 424. Channel 1 data and status, channel 2 data status, channel 3 data status. You get down below there, then you get into D431, the parameter setting, channel 0 signal type, data type, the min, the max, and the filter setting. And you've got that for each and every channel on the card. So again, you can monitor those in the PLC if you want. You can adjust those values in the PLC as well. Okay. That's analog. Okay. And that was an input. Let me put on an analog output card so we can look at that. So let me grab, let's see, I'll grab an FC6A J4A1, which if I click on the card, you can see down at the bottom right, it'll show a little bit of information down here about the card. FC6A J4A1, analog input, I want an output, so let me get rid of that. I need a K4A1. Okay, so that's analog output. It'll tell you the I/O terminal's got removable screw terminals, no input range. It's got 4 outputs, the output ranges, all this kind of stuff. The dimensions of the card, all that kind of good stuff. Now, if I want to configure that output card, click configure. Again, do kind of the same thing. I've got to specify a data register allocation for it to start with. Same checkboxes apply. I've got FC6A compatible mode here if I want to use it. I'm converting a program from an FC6A, FC5A PLC. I can use the data registers to set the parameters of the card, just like I could the input card. I can come down and pick the signal type, again, for each channel. And for this card, it supports 0 to 10, minus 10 to plus 10, 0 to 20, or 4 to 20 milliamp. So I can configure whatever I want for each individual channel. This card is a 12-bit card. So what that means is I'll have maximum values from 0 through 4095. Or in this example here where I'm doing minus 10 to plus 10, I can split that across the 0 and go minus 2048 to plus 2047 if I want. Likewise, I can adjust the range and specify that to be, whatever numbers I want in here. Maybe I want to scale the 0 to 10 to the default range. Maybe I want to scale that to, 0 to 1,000, for example. Okay, again, that's just changing the linear scaling of that particular output channel. Okay, the way the analog outputs work is in these data registers here, this data column, D1000, 1002, 1004, 1006, whatever value that I write into that register. For example, let's look at analog channel 0, output channel 0, 0 to 10 volts. I've got it scaled from 0 to 1,000. If I write a 0 into D1000, that's going to send 0 volts out of the card. If I write 1,000 into D1000, it's going to send 10 volts out that card. And any value I write between 0 and 1,000 will be scaled linearly and send that voltage out the card. And it works the same for everything else. Okay. For example, analog channel 3, 4 to 20 milliamps, I'm using binary data. When I write a value of 0 into D1006, it's going to send out 4 milliamps. When I write a value of 4095 into D1006, it will send out 20 milliamps. Any value that I write between 0 and 4095 gets linearly scaled and will send out between 4 and 20 milliamps. Again, on a linear scale. Okay. And if you guys remember, if you were around and saw the scaling webinar, we did an example in there where we used different methods of scaling. So if you do have something that's not linear, you can use the XY format set instruction and the either convert X to Y or convert Y to X to use nonlinear scaling. And you can use those for linear scaling if you want as well, just they're really handy for nonlinear. All right. And again, if we wanted to specify an internal relay down here to be able to modify the parameters of this analog output card by values and data registers, we can do that as well. And they work the same way as for the input card. All right. So that's configuring digital inputs, configuring digital outputs, analog inputs, analog outputs. Let me put a card, an expansion card module on here as well. Let me grab that. I'll put this out here on the left-hand side. And let me grab a digital I/O cartridge, and let me grab an analog I/O cartridge. Okay. All right. So the digital I/O cartridges, if you remember, we said it didn't matter if it was an input cartridge or an output cartridge, based on the slot position. Okay. Slot 1 used 630 through 633 for digital. Slot 2, this bottom cartridge slot, used 634 through 637. This happens to be an input cartridge. You can see I634, I635, so on. If I were to grab a output cartridge, input there, we're still going to have the same 634 through 637. It's just going to change the output. Okay. So again, for the cartridges, it doesn't matter whether it's inputs or outputs. The addressing will start the same way. It's just whether it's an I or a Q. The analog cartridge, again, these use special data registers. Okay. So if I click on configure for this analog cartridge, it's in slot 1. and I picked the 0 to 10 volt cartridge, you'll see those use registers, special data registers, D8170 through D8173. Likewise, if I put another analog cartridge in the bottom slot here, and if I configure that, those use special data registers 8174 through 8177. All right. All right. Now, let me do an example here of the remote I/O. Let me grab an expansion interface module here. I'll put a master module right in here. I'm going to get rid of one of these I/O cards. I've got too many in there. Okay. So there's my master. Okay. And if I grab a slave remote I/O cartridge and drop it down below, let me move this out of the way a little bit here. Scroll that down, then you can see there's my master, everything connected. This is my first slave, my first node. And again, it's got an input and an output Ethernet port. So if I start hanging digital inputs or digital outputs off of that, you grab an 8-point digital input card, stick on there. Again, those I/O here, since that's node 1, the digital I/O starts at 1000. So my first input card will start at 1000. If I grab an output card and put on there, that will start at 1000 as well. Okay. And again, the I/O is mapped the same way. If I add another 8-point input card, that starts at 1010 through 1017. And that's just because my first digital input card on this node was 1000 through 1007. So my next one starts at 1010. Okay. Outputs, again, they work the same exact way. So your digital I/O is automatically mapped just like it is regularly. It's just based on the node number. Node 1 starts at 1000, node 2 starts at 2000, node 7 starts at 7000, and so on. Analog, again, same way we've always done. Configure a data register where you want it to start, and you configure it just like normal. Okay. All right. Well, that's all the information I've got for you at this point. So that shows, again, digital I/O mapping, analog I/O mapping, and as well as this remote master and slave mapping. And just, I didn't really describe it too much, but where this comes in handy is if you've got I/O distributed across your plant floor and you don't want to put a whole other PLC in place, you can do this. Okay, just an option for you. And again, this way, all the code, all the control resides in the PLC. Right? There's no extra code to write in any other PLCs. You don't have to map any data. You don't have to do anything extra. It's really done for you just as if all the I/O were hanging off of one PLC. All right, let me take a look and see if we've got any questions. And let's see. The first question says, can you please add this link of recorded videos to your email sent to us by Marcom or add it as a hot link in the recorded sessions for show? Yeah, I can ask Marcom if they'll do that. I'm not sure if they will. But I can certainly put that link to the recorded videos and the link to the webinar material in the Q&A document, so it's in there for you. Sure, absolutely not a problem. Happy to do that for you. Let's see. Mr. McNeil says some of the FC4A expansion cards do not match the FC6A expansion cards. Yes, that is true. Some of the FC4A expansion cards, like on the outputs, were 16-bit, and the FC6As are 12-bit on the output control. Are there plans to improve those components? It's something that we've talked about. There hasn't been a huge issue. I know we've had a couple of issues with a couple of customers in particular, but at this point, no, there aren't any plans that I know of to adjust the output cartridge or output cards rather to make those 16-bit on the 6A. Let's see, the next question is, does the FC4A compatibility mode affect the maximum number of FC6A cards and or cartridges that can be used together? Excellent question. No, it doesn't. You can use FC4A compatibility mode, and that has no effect on the maximum number of cards or cartridges. Really, all that's going to do is just adjust where the data gets mapped to in the PLC. Let's see. Next question says, can I export the module configuration for my machine documentation? Excellent question. I don't think there's a way to do that. I don't believe we can export it. Let me go into a card here. The digitals, I know you can't. Let me grab it. Did I delete the analog? No, there's an analog. No, there's not a way that I know of to export the module configuration. Next question, do the input cards accept 0 to 5 volt inputs? I did not see the option for the signal types. Yeah, you can use 0 to 5 volts on these, no problem. For example, if I go into the FC6A J4CN1, even though I've got my signal range of 0 to 10 volt DC, I can use 0 to 1, 0 to 2, 0 to 5. If I change this to -10 to +10, I can use any range within that minimum and maximum. Now, what will happen is, let's take the 0 to 5 because it's easy and I can make the math work. And again, like I told you guys on these, I'm not that smart of a guy, so I got to pick something that's easy. Let's say we're doing 0 to 5, right? I've got it configured here, my analog input 0 configured to 0 to 10 volts. I've got it set for binary data, 0 to 65, 535. If I want to use this and pump in a 0 to 5 volt signal, can I do that? Absolutely, no problem. Leave this exactly the way it is. What will happen is, instead of getting a maximum of 65, 535, I'll see values from 0 to half of that, 32,767, from 0 to 5 volts. So I won't be using the full range of the card, I'm just using half of it. But yeah, you can absolutely do that, not a problem. Let's see, the next question. I understand that there is an expansion card limit per base unit. Is there a power load on the base unit power supply that should not be exceeded for 5 volts and for 24 volts? Yeah, there is. Good question. So what the question is asking is, and let me see if I can bring this up here. Let me get rid of some of this stuff. If I can scroll down, if it shows it. No, it doesn't show it. It's not going to show it here. It shows it up to the top. Okay, that's fine. So if I click on just my PLC in general right now, okay, it'll show me up here at the above that, at the top in this little window, it will show me my allowable current on 5 volts and also my allowable current on 24 volts. The internal communications bus that we use for the I/O cards is based off 5 volts. Okay. Your analog cards, when you plug them in, you have to provide them with 24 volt power. But the digital cards get powered by the bus. So that's why in this example, we're seeing a lot higher current for the 5 volt versus the 24. I've got more digital I/O cards here than I do analog, but there is indeed a maximum load, and it'll show you that up here. So you can see as you are dragging in, let me get rid of a couple cards here just to show you. Like if I get rid of a couple of these cards, you can see up here that the I/O draw changes. Okay, good question. Let's see. Unrelated question to today's topic, that's fine. Whenever I use M8120, the initialized pulse, the initial pulse will not move values into data registers such as a move state. I noticed this after a program download. I should test this after a power sequence. I don't know. I'll have to check that out. I'll have to look at it. On the FC6A Plus with a max of 63 I/O cards, if I use all 32 I/O modules, are we still able to use 63 cards? We are not limited by I/O. I have not tried that, but I believe that is the case. I will try that and find out. But yeah, the only thing I know of is the limitation is based on the total number of cards if you're doing the master-slave configuration. I'll try that out, and I'll answer that in the Q&A document. The next question is, can the remote I/O expansion modules be used with the FC6A all-in-one or the FC6A brick? Is that true? Yes, that is absolutely correct. The remote I/O master and slave modules will only work with the FC6A Plus. Let's see, the next question. Can you use the Bluetooth cartridge on the remote I/O slave? I don't think so. I don't think so. Let me try it. I don't have a definite answer. Let me try it. Let me see if I can put a cartridge base module down here. No, it won't let me do that. Which I guess I do understand, because this is not really a PLC down here. This is just kind of like an I/O expander. So to answer the question, can you use the Bluetooth module on the remote I/O slave? No. What you would need to do is use it on one of the cartridge expansions on the main PLC. All right, next question. Curious to know, what is the maximum number of simultaneously connected IDEC PLCs that you have seen or heard of in operation in the field? Literally hundreds. It's in West Texas in the oil fields. I know the guys down there have PLCs on every single oil wellhead, and they're pulling the data back to the PLC and then sending data from the master PLC, if you will. And this isn't using expansion I/O. It's everything set up over Modbus. But it's pulling data back into the main PLC, and then that main PLC is pushing data from all the wellheads back into their into a software package that they've got running back at their headquarters. Let's see, the next question, can you click on the Node 1 expansion module and see the power supply usage for it? I'm not trying to remove it. Let's see. No, it doesn't. Let's see if I can do any properties or anything. No, I can't. So if I click on this, it won't show me any of the power that's being used on that particular node. No, it doesn't. Good question. The next question says, I've missed a couple of the webinars. Will all the videos be posted somewhere? Yeah, they will. All the videos are going to be posted. Let me bring up the PowerPoint. I'll show you that link so you guys can take a screen capture of it. So bear with me. Make this bigger. Okay, here. So all of the recorded sessions, those are posted on our YouTube channel. And like I said, if you guys want to take a screen capture of that link, you can. I will start putting it in the Q&A documents and stuff that get posted as well. But that's the link to the recording, the actual webinar, if you want to watch them back. It's on our YouTube channel. And then the training material from all the webinars, again, the PDFs of the presentation, the programs that we develop, and the question and answer document from that particular topic are all available for download at that link there. And again, you can take a screen capture of that. And that will, again, this has all the webinars that we've done and all the materials that are available to date. Basically, you just click on the download button that is beside the webinar topic that you're interested in, and that will get you all those files. Let's see, the next question is, I've attended a number of these. Is there a certificate of participation available? I need them for PE license, professional development hours verification. I'll check with our Marcom department to see if that's something that we can put together. As far as these qualifying for professional development hours, you guys would know better than I will if these will qualify for that. I do know that the live trainings that we do, the 3-day trainings that I know some of you guys have been to, Those we have had certified with IEEE that do qualify for professional development hours or continuing education units through them. But I don't know if these webinars will count, but I can certainly check with our Marcom department to see if they can make up some sort of certificate of completion for that. Sure, I can check on that. All right, guys. Well, that's all the questions I've got. I want to thank you very much for taking the time to attend this morning's webinar. Again, we're going to repeat this session again at 2 p.m. Eastern. And so if you want to attend that again, you're certainly welcome to do so. If not, hope to see you guys again on one later in the future. And stay safe, stay healthy. We'll talk to you later. Thanks again.